Okay, we want to find the volume swapped around the y-axis by the area between the function x is equal to x squared plus 5 between the value y is between 10 and 25. Okay, so the first step is to define our element. This height is about dy and this length is x, right? If I'm going to write down the volume of this element, we show with the dv is equal pi x squared dy. Why? Because this is like, you know, a cylinder. The area of the circle times the height. So to find the volume from this point to this point, we have to get the integration x squared dy. The other side is the total volume. And the right side is just, you know, pi x squared dy. We cannot directly solve this integration because we have a y here and we have a x here. Okay, somehow we need to change x to the, you know, y. If I write it instead of x, I put it, you know, as a function of the y square dy, then we can solve the integration or find the answer. How are we going to do that? We know the relation between x and y. If I use this one, I can just rearrange it and write it as a x is equal half times y minus 5, okay, square root. If I just replace it here, square root y minus 5 divided by 2 power 2 dy. So everything is y now. Pi is constant, we can take it out of the integration. Y0 is 10, y1 is 25, and then we have a y minus 5 divided by 2 dy. And the answer is pi divided by 2, 0.5 times y squared minus 5y, the limit is from 10 to 25. And if I just replace this value to integration, the final answer will be 93.75 pi or 294.54 unit cubes. That's the final answer, okay? So, just to review it again, the first step is to define our element. When we have the element, we can write the dv, the volume of this element is pi x squared dy because this is the cylinder. And then apply the integration both sides of this equation. The left side is the volume, and for the right side, we need to replace x as a function of the y to solve the integration. How we can write that? We have the relationship, we know the relationship between x and y. We just need to rearrange it and have the x at the left side and everything at the right side. If we just replace this function here and apply simplification, we'll have this one, that's the, you know, the final one, and that's the easy integration, and we can find it.